to the next presentation. Now we are coming to the most important part when it comes to the cost. So that's nothing but the metallization pace. We have seen the mention of it almost in every presentation. So coming to the state of the art, which is the screen printing, we have Kaien Chang, Vice President of Technology overseas at Solamet, who is going to talk about the novel low temperature pace development for heterojunction and also beyond, which is perovskite tandem cells. So Kaien, the floor is yours.
Thank you. Let me share my slide. Okay, thanks for TaiyangNews. So today I'm going to share some of the novel, sorry. Let's see, are you able to see my screen now?
Yeah, it reappeared now.
Okay, so I'm going to share some of the novel low temperature paste development for HJT and Perovskite tandem cell. So the agenda for today is I will give a roughly introduction about the Solamet and also talking about some of our offerings for the low temperature application and also talking about the main topics today for the alternative approach for the low temperature paste. And then I will also give some of the quick look at the study of the silver coated copper, which is also one of the very hot topic for the metallization paste for HJT. And next one is go to the conclusion. So for Solamet introduction, I think that probably most of the people know that the DuPont's in the past. So basically for Solamet, we are basically the former DuPont metallization paste as a brand name Solamet. As of 1st July last year, so the Jiangsu Sorter Electronic has successfully acquired DuPont Solamet photonic business. So now basically we are independent paste supplier in the markets, and we basically inherits all of the properties from DuPont's Solamet, including the people, asset, and of course the technical properties, including the IP. So this is so now we are using, now company name is using our previous brand name Solamet as our company name Solamet. And here, as I just mentioned, seems that we are inheriting all of the DuPont's assets and also the people. As you can see, basically we are inheriting previous DuPont Solamet's global layout and organization. So for commercial team, as you can see, basically we have the whole headquarters in Shanghai, and also have the sales and service team in India, Malaysia, and Taiwan. And for technical center, we have two dual technical center in Shanghai and Taiwan respectively. Besides that, we also have our R&D team in US. Actually, our CTO, QJ, actually located in US. And here is talking about one of the for our global presence. One very unique properties that we actually have published, one of the few paste supplier who have dual technology centers to strategically serve our customer in China and outside of China. As you can see in this chart, basically in this kind of dual technology center, we believe that we can better support our customer, no matter in China or in overseas. And besides what I just mentioned about the heritage from DuPont, I think that I also would like also to focus on what is the new change to the Solamet. Seems that right now we are a relative smaller company comparing to DuPont. So suppose right now we have a much better speed and feasibility as a new company, as a separate company at this moment. So let's go into the topic today to talk about the low temperature offering we have in the markets. We actually back to DuPont old time. We already have the low temperature offering in the market for thin film solar cell, PV412 and PV416. This is actually a commercial product for thin film solar cells since 2009. As you can see, this is a room temperature operation paste, but the drawback is that it cannot compatible with the fineline screen at that time. And in order to have a new offering for HJT, basically right now we have the other new low temperature offering like a PV42A, which is our curing epoxy paste system. This is probably well known in the markets. I mean, this is the most this is kind of the similar system to most of the low temperature paste right now for HJT. And 42B, this is probably will be today's focus. This is the low temperature sintering paste for HJT. As you can see, it got a very good fineline capability and also able to operate in room temperature. And the last one, we'll also talk a little bit about the PV43B, which is the ultra low temperature paste for Perovskite, which is able to be, which is also compatible with the curing condition like 120 to 130 degrees Celsius. Okay, so let's talk a little bit about the 42A, which is the curing epoxy system, which is the most well-known system for low temperature paste system for HJT at this moment. As you can see for this one, I don't want to give have too much slide to talk about this, but for our epoxy system, as you can see, we have a superior bulk resistivity and also have a pretty good fineline screen capability. Later on, I will also talk a little bit more about this. And before I move into the 42B, I want to show you what is the current span for HJT metallization process. As you all know, for the current metallization process comparing to the PERC mono front side, as you can see in this table, you can see the printing speed is much lower comparing to the PERC mono front side paste so far, which actually leads to a lower throughput, which could be an impact from cost point of view. Another issue, another pain for HJT metallization is the fineline screen capability. As you can see, for the PERC mono front side now actually can achieve can be compatible with the screen opening like a 12 to 15 micron based on the knuckless screen. But as you can see for HJT, probably now it's only can achieve like a 20 to 24. As a result, you can see the laydown difference because of this fineline capability. So for the PERC mono front, for the PERC mono, I think that the basket laydown could be like 8 to 11 milligram per watt. But you can see the HJT is much higher comparing to the PERC mono metallization paste. So of course, I think in the previous presentation, we already learned about a lot of laydown reduction approach. But for the laydown data here, I think that for HJT here, basically is cool. Some of the special advanced technology like a zero bus bar or smart or some of the technology like the silver coated copper. This is in general situation. Okay, so in order to try to solve the current span for the metallization paste of HJT, actually we have an alternative approach for the low temperature paste. Basically, it's kind of very different from the current epoxy system, which now 42B is a low temperature sintering paste system. Basically, as you can see the pictures in the left hand, the morphology is very different to the incumbent epoxy system. And if you and basically you can see the feature, we are able to achieve a very low laydown basically, if you look at the external testing result in the left button, basically we are able to achieve by appropriate optimization from screen and also the multiple bus bar design. We are able to achieve a significant laydown saving without the efficiency loss. This is the first feature. And the second one, you can see that we are also able to achieve the excellent fineline permeability. And the main reason is that if you look at the SEM picture, cross-section SEM picture in the right-hand side, most of the epoxy paste, low temperature paste actually contains large flake silver in the system. But if you look at the cross-section for 42B, basically you will not able to see any flake silver. We are not using the flake silver approach for low temperature paste. So in that case, as you can image, by screen printing, I mean the fineline screen printing, seems that there is no flake silver contained. So basically, there will be much better paste transfer during the printing, which enable much better fineline permeability. And the third one, also talking about we also believe that will have a better context to texture TCO. As you can also see in the SEM pictures, for seems that because of the silver selection difference, because of the large silver flag, you can see basically the context to the ITO is not perfect, but best seems that we are using the different system without a bigger, large flag silver. As you can see, the contact to texture TCO is perfect. And as also I mentioned, seems that this system is very different to current epoxy. We are actually no need to operate or store or transportation at the low temperature. We are able to be store, transportate, and also operates in the room temperature. So I suppose that this kind of a property will lead to less wastage and also the lower transportation cost for HJT paste. And here, next page, I'm also to talk a little bit about some of the internal permeability simulation to try to understand the printing performance for 42B. So as you can see, we are trying to use a very harsh screen to try to test the permeability. So we are using the 400 mesh with 80 micron wire diameter mesh screen to conduct this testing. As you can see, for traditional epoxy paste with the flake silver inside, you are able to see, at the 34, we start to see the light broken, and at the 28, we are even able to see the line during the printing, after the printing. But 42P still can remain the good printing quality by this kind of a harsh mesh and opening. Next one, I would also like to elaborate more about some of the printing performance comparison. This time we are using a special design screen to conduct the testing. As you can see in this picture, basically we designed a different opening in one screen with a repeated pattern from 20 micron to 10 micron, and also try to and also design the pad at the beginning, at the end of the line, in order to easy to measure the line resistance. So as you can see, so after to print the different paste on this kind of a pattern, then we try to measure the resistance by the 4-point pump to understand the resistance response along with the different finger opening. So here is the result, as you can see. So basically, you can see we try to test it 5 different pastes. Incumbent A, incumbent B is the traditional epoxy system, and 42A is the Solamet epoxy system, and 42B is just what I mentioned, the low temperature sintering system without a flake silver approach. And the last one, as you can see, we also included one of the excellent OK control, which is the PERC mono front side, to be compared with those HJT low temperature paste. Of course, seems that we are going to measure the resistance by 4-point pump. So for all the low temperature paste, we are conducting the curing condition 200 degrees Celsius with a 7.5 minutes curing time. Of course, for the PERC mono frontside paste, we are doing the drying and also the high temperature firing in order to to measure the resistance. So you can see the result in the right in the left hand side. Basically, for the current markets in Cuban epoxy system paste A and B, you are able to see that for example, you still can see the good resistance for 20 and 17 opening, but when it's down to 40, you start to see significant resistance increasing with the large variation, which means that they're starting to see the light broken to impact a lot, impact significant to the resistance performance. But if you look at the 42P, the Solamet epoxy system, we are able to still show the good printability until 10 micron opening. And for 42B, basically you can see almost can match the same level for the PERC mono frontside paste based on this kind of resistance check by the special design pattern. So from this very simple simulation testing, we conclude that the traditional low temperature paste with the epoxy system with the flex silver basically definitely show the printability concern when moving to the fineline screen. And Solamet's 42A enable the fineline screen, and for Solamet 42B actually show even better printability, which is almost the same level to the PERC mono frontside paste. So we believe that will be one of the alternative approach. We are able to try to solve the two pen I just mentioned, comparing to the PERC mono frontside metallization process. So for page 14, here is the further elaborate by looking at the light quality by from microscope. So as you can see, basically the result is pretty aligned with the resistance testing result for incumbent A and incumbent B from right hand to left hand side from 20 to 10 micron opening. You are able to see the light quality start to become worse and worse, and you are able to see the light broken or even very dash line when moving to 10 or 12 microns. But if you look at the 42A and 42B and also the PERC mono frontside, you are able to see the very different printing quality, which is pretty aligned with the previous resistance measuring data. So you can see that here. I also try to summarize the ratio for resistance over 200. So basically, you are able to see the big difference for the different paste, and basically 42B is able to achieve a similar level to the current PERC mono frontside paste. And also another advantage I just mentioned, we also can see from this pattern, the laydown is also one of the advantage for this new system, comparing to no matter for PERC mono or the current epoxy system. Next one, I'm going to talk a little bit about our ultra low temperature approach for the Perovskite tandem cell. So as you know, for the current HJT paste, the curing condition is about 190 to 200 degrees Celsius. But for tandem cell or Perovskite, I think all of you know that we are not able to use this high processing temperature. We need to have a curing temperature lower than 130. So actually, based on the PV42P, we actually further conducting some of the advanced development for this kind of paste. So as you can see, comparing 42B and 43B under the different curing condition, for 42B, once we move to 130 degrees Celsius by 10 minutes curing time, you can see the bulk resistivity is like 40 to 50 times higher, but 43B still can remain the same order, just slightly increased from 4 to 66, 10 to -6 ohm cm. So basically, this paste, we are able to show the very good resistance under the low temperature, 100 to 130 degrees Celsius. And just like I mentioned, since this system is also based on the development from the 42B, that will be also have the excellent fineline printability and low laydown, and also the room temperature operation properties. But you know, I just elaborate all the benefits I just go through for this new novel low temperature sintering paste. But I also would like to talk a little bit about some of the challenge of the current paste 42B and 43B. One of the major issue we see so far is just only one by hard water testing. So as you can see, by the condition of 85 degrees Celsius with 15 minutes, we are able to see, and then after that we test it by 3N tap. You are able to see the peeling from this kind of testing, and we try to separate the temperature and also the water impacts for this kind of issue. As you can see, we try, for example, the 30 degrees water with 15 minutes, and also the 8.
I'm sorry to interrupt you. You have to wrap it in 1 minute.
No problem.
Please.
So another one is 85 degrees 24 hours. You are able to see that you know, for 80 degrees Celsius, we are able to see the perfect performance without water. But even at the low temperature, 30 degrees by water, still to see this kind of peeling issue. So basically, we conclude the water is the major issue for this one. For this kind of a new type paste, I think we need a better module encapsulated material, and also the product and the product modification still needed. Due to the tight constraint, I probably will skip the silver coated copper study and go to the conclusion. I think we will try to need a further collaboration with the cell module customer to solve this hard water performance concern. But we believe this alternative low temperature paste approach can actually have a significant breakthrough in terms to improve the HJT throughput and also the fineline screen capability, and also the laydown, to try to solve the major two pain spot for the current HJT metallization process. And we are also continue to invest our resource to develop the new paste, no matter either the silver coated copper and the low temperature sintering paste. Okay. So this is pretty much. Okay.
Thank you very much. Unfortunately, we don't have time for the questions, but you know, please stay online, and if there are any questions in the chat, please try to answer them.
Sure.